Oh, okay, cool.
Nice. Good stuff. Good stuff. Last catch up. Okay. Cool. Oops. We change that to that. 1 second. Oh wow, I can see all the new buttons now in Zoom. Just give me 1 second. Okay. Cool means. Right. Okay. I couldn't see the whole of the discussion meetings. I had to do something, but I will watch the recording because apparently it went really well. All right, cool. So, Dave, you want me to start?
Yeah.
All right. Yo, what's up, everybody? To those of you who were with us last semester, welcome back to those new faces I see in the crowd. Welcome. This is BigTh AI Pioneer section. Pioneers. We rebranded, as you know, if you attended an info session from the product section to Pioneers, because that one, it sounds cooler. But it just sounds cool. But yeah, cool. So let's go ahead and get started. Well, before that, I just want to iterate that I like to keep like a cool, uh, in-calm environment. Sorry, not calm, but like fun environment when I do my meetings. So if you ever want to like say something, shout something out, have a question, something, feel free to unmute yourself, or even just like say in the chat, and either me or one of the other leads will answer your question. Or if you just like want to tell me a joke in the middle of the lecture, that's fine as well. If it relates to the slides, even doesn't relate to the slides, I don't really care because like online school has really low standard for comedy, which is really saying something because I'm really low student for comedy. But anyways, yeah, without any further ado, let me take a sip of water. Okay, and let's begin. So today we're going to be talking about Python, DataFrames, and Google Colab. And I'm sure, as many of you know, Python is the main language we're going to be using this semester to code our projects. DataFrames are an important part of that. We're going to get to that later. Colab is the IDE, if you will. It's like Eclipse for Java. Sorry, Eclipse when you use Java. That's our coding environment. So we're just going to go over those three today. So table of contents. First, we're going to go over some basic Python, and that's going to take a minute. And then we're going to get to the good stuff, which is DataFrames and Google Colab. So I'm assuming, oh wait, he's a pointer. There we go. There we go. So I'm assuming this stuff is going to take majority of time, but let's see. Because I assume, I'm going to, by the way, I forgot to say this at the start, but I assume most of you have the equivalent of 131 knowledge. So yeah, it's going to be a little less hand-holdy in that sense than last semester. But all the ML concepts we'll be doing from scratch.
What did that mean?
No, I was just saying that I assume that you know stuff like arrays, functions, that kind of good stuff.
I know about it, but I'm not too like.
Okay, no problem. We can do that. We'll I'll make sure everyone's on the same page. I'll try to best my ability. But yeah, cool. Did you want to say something, Rohito?
Oh yeah, yeah, we'll be providing resources in case you're confused or you want some more reading, and you can always like reach out to any of us outside meeting times.
Yeah, I just assume that you know something about programming, just like not a total expert, obviously, but yeah. If you ever have a question, just stop me right there. I will literally stop and like explain it from scratch if you want to. Okay, yeah. Without further ado, so first of all, since we go to U of D, they chose to teach us Java for some reason. Let's go over some quick differences between Java and Python. So the first difference right off the bat, as you can see, is that Java has a main method, which is like where the execution of the code actually starts, right? You have to write that really bulky, messy, align public static void main, blah, 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 right? In Python, you can code wherever you want. I'm not kidding, you can code wherever you want. The only condition, though, is that you have to code from top to bottom. What that means is, well, I can show you in my collaboratory. So if I, this is how you declare a variable, by the way. I'll get to that later. But if I have a variable here and I want to print it, right? This works a-okay fine, right? Yeah. But if I put this somewhere else, and if I put it beneath it, actually, then I'm going to get into an error. Oh, apparently I didn't get into an error, but did I?
Oh, you have to like factory restart it. Yeah, the runtime.
Ah, yes, correct. Thank you. There we go. I never thought I'd be that excited to see an error, but there it is. So if you always have to declare the variables that you want before you actually use them, right? That's the one caveat of being able to go without a main method in Python, right? And the second main difference is that whereas Java, you had to declare types. You have to say string facts equals I hate online classes. You have to actually say the type string before you actually do anything with it. And int meaning of life, blah, blah, blah. You can literally just put the variable name and the value. That's legit it. Like if I wanted to make a variable, a string variable called dog, I would literally just type in, or I could just like show you. I could literally just type in dog equals puppy. I don't know why I chose to do that, but yeah. And that's fine. There's no type error. There's no any error. That's literally fine. You just have to do that much. Right. And that becomes really convenient for us AI programmers, if that's what you want to call us, because we don't want to focus on all those little tiny details of types and stuff. Right. Okay, cool. So
I just had a
summary.
quick question.
Yeah, sure. Go ahead.
So like what you just did, right? You made a string. So like what if you call like a method that uses, or like a function that uses like an int on that? It'll fail, right? Or like what'll happen?
Yeah, so the thing about Python is that like it knows the runtime. Sorry, it knows the type at runtime. So yeah, it will fail at runtime, but it won't give you a compilation error, right?
Oh, I see.
Because like,
Okay.
yeah.
Okay, thank you. Yeah.
What does compilation error mean?
So compilation error, you don't really have to worry about it too much, at least in this context, or at least in this club or anything. But compilation error is basically like if you try to run it, and well, we just had a compilation error right here, the name error. Oh, actually,
okay.
wait, I'll just like demonstrate that again to make it clear.
Wait, how do
But-
we have a compilation error if Python's not compiled? I thought it's just interpreted.
Well, it's not exactly a compilation error per se. I'm just calling it that because like that's what
Okay, fair enough.
Java programs are familiar to.
Yeah.
Yeah, technically it's like runtime, but yeah. But as to your question, I don't know who asked me that, but like yeah, so this is what it's like, a compilation error, but not really. It's basically just like the things that have to do with your syntax that are incorrect. Actually, wait, this is an example of a runtime. Sorry, my bad. This is an example of a runtime error because there's nothing wrong with the syntax. The thing that's wrong with it is the fact that you use a variable before it was actually declared. Yep.
Okay. Is that the same thing as a compilation error, basically? Or is that a whole different thing?
Someone has a cool ringtone.
That would be my bad. Sorry.
Oh, no problem. Yeah, so yeah, they're two different things, but in Python they're more or less the same, you know. But yeah, again, I don't really want to get too much into differences because they're not important. Just know that errors exist in Python, right? Like, yeah, invalid syntax. This is like a compilation error, right? Because something is wrong syntactically. You don't declare equals in $ signs, right? Cool. And next is conditionals. All right, so if-else statements. So unlike Java, where you needed colons where you need curly braces around your if statements, we're going to be using colons in Python. What that means, you can see right here, give me a little pointer. You can see right here, right after the if statement, we have a colon, followed by everything that's under the if statement has to be indented. And that is the requirement because we're not using curly braces. Otherwise, Python's not going to know what's in the if statement, what's not in the if statement, right? So indentation is key here. So if I just go to Colab again, Let's make a story. Say is happy equals true. I can't type apparently. Is sad equals true. So if I do is happy, right? I have to put a colon after the if statement, and then, well, colon automatically indents after you put an if statement, but let's say it didn't, then I would have to use my tab key to manually indent it, right? And I would say print, you know, whatever. And like everything in under the if statement has to be indented. Otherwise, you're going to run into what we call an indentation error. I'll show you right now what that is. So yeah, expected an indented block. So you always have to put the indent here. Otherwise, you're going to get an error. And just another small thing, instead of else if, like you're used to in Java, we have elif, right? So that's another thing. Any questions? All right, let's move on. Lists, which are basically arrays, but better. So I know a lot of you here from 132, Nelson, because I told him to post in Piazza. So I'm really happy with that. Just quick in the chat, tell me if you're from 132 Piazza. But I heard this phrase on in like my third week in 131, and he said array lists are like arrays on steroids. I'm pretty sure Nelson said that at some point. Well, I'm going to be saying lists are like array lists on steroids. What does that mean? So just like with variables, you don't have to declare any types for lists, right? You can literally just put name equals, and then you use square brackets and you put whatever you want in the list in between them, right? And indexing works the same way as in Java. You put the square brackets and the number of the index you want. And we also use zero indexing in Python. So that's not different at all. Let me show you a couple of things you can do with lists because they're really powerful here. So ice cream. I want anyone to shout me out some ice cream flavors. Literally just shout it out.
Chocolate chip mint.
Chocolate chip. I'm going to short form because I can't English right now. What else?
Vanilla.
Vanilla. All right. That's my favorite flavor, believe it or not. What else? Strawberry. There we go. And one more.
Cookies and cream.
Cookies and cream. All right. Cool. So basically, if you ever want to add something to a list, it's really easy. You just say the name of the list, dot append, and give me one last flavor of ice cream.
Chocolate.
Okay. Yeah, I realize there's not many left, but yeah. So you do that, and let me just get rid of these. You do that, and I'll show you that it is now in the list. And I'll get to for loops as well, but for the sake of demonstration, let me just. Right. Cool. Right. Oh, yeah, I probably should have done this, shouldn't I? Yeah, so you can actually see it being added. So as you can see, our list now has chocolate included because we use the append method. And if you ever want to remove something from the end of a list, you would just use the pop method. And then if you print it again, we'll see that it's not in the list anymore. Oh, right. So for pop, you actually have to enter in the index of what you want to remove. So let's just remove the first one. Yep, the first thing isn't there, which was chocolate chip mint. Yep. So lists are really powerful. They don't even have to be the same type things in the list. Like you could literally just put a number here, and it would not matter either ways. And if you want to initialize a list, sorry, I'll get to your question in 1 second. So if you want to initialize a list, you can literally just put empty square brackets. That's an empty list for you, right? There's no new or anything like that. Does someone ask me something?
Yeah, but chocolate chip mint is still on the list.
Where?
Chocolate chip mint. upstairs. Oh, is it like two separate lists? Like the,
Yeah. I printed it kind of weird because there's just no new line. But
Oh,
yeah.
okay.
Yeah. So any questions on lists? Going once, going twice. For the people in 330 Hicks, you know what I'm talking about. Okay, so that's lists. Gonna be very important. Dictionaries. We're gonna be using these indirectly, I guess, but not like a core thing of what we're doing. But essentially, dictionaries, for those of you in 131 who haven't, or even, I don't think, they haven't covered in 132 yet because it's only the second week. So basically, a dictionary is kind of exactly what a real life dictionary is. You have a key or like a definition, I guess. Sorry, the word in the dictionary analogy, and you have a dissociated value, the definition, if you will, right? So a really quick example here, I have a dictionary called ages, and basically all the keys in this case are names of people, as you can see. And the values are the ages corresponding to each person, right? So I'm Samrat, I'm 20 years old. I can't believe it either. And we have these other rock stars who are very old, actually. Damn, that makes you think. And basically how you do a dictionary in Python is that you say the name of it equals, and use these curly braces, the kind of like how you use square braces in lists, and you put the key, which in this case is a string, followed by a colon, and then the value. And if you have more key value pairs after that, you put a comma, right? So that's how that works. Just remember, it's key value pair, key associated with this value. That's all you have to remember for dictionaries. Did someone have a question? Okay, cool.
Wait. Annie says,
sorry.
what's the purpose of these?
Oh, dictionaries?
I believe so. Annie, is that what you were referring to?
Yeah.
So dictionaries, I guess we'll see the use of them as we use them. We'll go into that a bit later, but you'll see that there is an actual use for these. Like, I don't know, I can't think of
one
anything
quick
off the top of my
example
head.
is to like if you have a list of like repeating values and you want unique values, you can just put every value in the dictionary and it will just save one value. So you'll get the unique values out of an array. So if you want to find some unique values out of an array, you can just put all of them into dictionary and it will save only one. It's like 2, 2, 2, and it will save 1, 2 instead of 3 2s.
Okay.
That's a quick.
It's like
example.
associating a value to something.
Yeah, I mean, like if you think of it like a phone book, then you can have like, you know, certain things where like, say you may not know the order in which you added people into like, you know, your dictionary, but you know that, you know, this person's name is in there. So if you index it by their name, then you can grab whatever necessary data is associated with them instead of having to remember where the hell they are in the list.
Perfect example.
Yep, just like Philip said, thank you for that explanation. It's whenever you want to like reference someone by their name in this example. And I should probably go over like how you would reference just to really drive home the point of why they're useful. So if I just like very quickly just did this, or actually, can I do this? Oh yeah, that's a big brain movement. Hell yeah. All right. So if I did this right and get rid of this junk, if I want to get the age of a specific person, all I would have to do is say the name of the dictionary and use the square braces and use my name, which in this case is the key, and it will print out the value associated with that key. Oh, I forgot the comment there.
Yeah.
Yep. Always test your codes, kids. Yep. So it just printed me the value of 20.
I have a question.
Yes, sir.
Can you have multiple values attached to like Samrat in the library? Like, can you have like age 20, height 5 feet, whatever, something like that?
So you're saying for this single entry?
Yeah, like for that entry, could you have multiple values attached to your name, or just one?
You can create another
could have, like, a
dictionary or
list.
an array.
Yeah, you can just nest them.
What you could do is, like someone said, you can have the name as the key, and then instead of one single value like 20 as the value, you can have another data structure like a tuple or an array that can store multiple things, and then you'd have to index them and remember what order you put them in.
Okay, cool. Thank you.
Yep. I just tried doing it like what you said. And so basically the key, if you have a key that shows up twice later on in the dictionary, it'll just take the last value past it. So in this case, the last value is passed as true. Because you can only have one key, a value pair. That's the whole point of a dictionary. So yeah, if you use a list or a tuple, you can kind of get around that.
Okay, cool.
No problem. Does that make it kind of clear, Annie, about the uses of the dictionary? I promise it'll become
Yeah.
clear when we, yeah. Okay, cool.
Thank you.
Yeah, no problem. Oh, sorry for that. Okay, we're making good time. Wait, I have functions and then, okay. So functions, we won't be using them much at all, to be honest, but I figured I might as well show you what they look like. So unlike Java where you have to do public, static, blah, 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 you get the point. All you have to do for a function is you use the keyword def, which stands for define. The name of the, oh wait, let me use a pointer. Use def, which stands for define. Use the name of the function, which in this case is add. And then you put the parameters here. And you don't have to specify the types of parameters, just like you don't have to specify the types of variable names. And then return same syntax there as you would Java. And just like in if-else statements, you put a colon next to the signature, if you will. And also just like in if-else statements, it has to be indented. All the stuff that comes under the function has to be indented. Otherwise, you'll get an indentation error. A cool, neat fact about functions that amazed me when I first was learning Python is that you can actually return multiple values. That's right, you can return multiple values. So what will happen is that when you call a function, it will return a list, I believe, of all the return values. So, and you just put, and if you want to, I'll just show you. It's always better to show people. And the way you would do that was that you would say return, and then you put a comma for the other return value you want, and that's it. So that's pretty cool. Any questions about that? We won't be really using functions that much, but I just wanted to show you. Okay, cool. And like I said, guys, I know I'm going a bit faster because like we have a lot of stuff to go through, but if you ever want to contact me outside this or even inside this time, feel free to just like ask. Okay, I have this. Okay, cool. So finally, we come to loops. So I'm just going to be going over for loops, not while loops, because that would be doing those in this club. So if you've ever done a for each loop in Java, that's what Python for loops are pretty much like. But for those of you who don't know, basically this range function, it produces a list of, I forget to use my pointer. This range function, it produces a list of numbers going from 0 to this number -1. So in this case, range would produce a list of numbers 0, 1, 2. And because of that, this loop will run for 3 times, like you said here, range 3. And if you go from the beginning, just say for I, and I is a variable, just like here int I is a variable, in range. So essentially, it's just I will take the place of each value in the list that range produces. So yeah. Another way you can actually do for loops, I did it a bit earlier, but I could do it again. So if I just put random numbers, you can also use you can also like make it like a for each loop in the sense that you put any name you want. I'll just say age. For age in the name of the list that you're iterating over, colon. And if you just use the name that you used at the beginning, in this case, I use age, it will go through each, age will be, it'll first be 3, then it'll be 2, and then it will be 5, and then it will be 7. So it's basically, age is basically taking the form of each index in this list, right? And if we just print this out, it does exactly that. So that's just another way to do it. But you can stick with this way if you already know the length of the, if you already know how many times you want to do the loop for. And actually, now that I think of it, you can also do this, and this being this. So there's a function in Python called len that stands for length, and it basically returns the length of any list or other data types that you want. So in this case, it'll suit our purpose. But since we're actually going manually and using the indexing for this one, we're gonna have to do that, use the I counter variable, and that should work pretty much the same. Yeah. Cool. Any questions about that? Okay. Okay. Stop. Stop whatever you're doing. Put all the pens away, put all your baggage to the side. We're going to do some demos. What do I mean by demos? You guys are going to tell me what I have to code, just so it really gets you, drills into your mind. So let's make a story. I want to make a character called Henry. And so how do I make a variable that's named Henry and has a value? Sorry, how do I make a variable that has the name character and has a value of Henry? Anyone want to shout it out in Python?
Yeah, it's character name equals Henry.
I'm just going to call it character for simplicity's sake, but yeah. Great. Character Henry. And Henry has a list. He has a list of his favorite TV shows, right? So how would I make a list of his favorite TV shows if I wanted to like write the TV shows directly in like this? How would I do that? I think I just gave it away actually. So let me just do it a different way. Let's just say we have a list of TV shows, right? That's an empty list I showed that earlier. How would I add new TV shows to it? Someone shout out a TV show name, then tell me how I would add it to the list.
Game of Thrones.
Okay, and then how would I add it to the TV shows list?
I think you would like. I actually don't know. I forgot.
It's like a
Problem?
quotation marks and a comma.
Sorry?
You put it in quotation marks, and then you put a comma. Might be wrong.
Brackets and then just equal it to another value.
Yeah, you could do that. That's the way you could do it. So you could set the first value in TV shows to be a Game of Thrones. That's one way you could do it. The other way is you could just use the append function and put your value you want to put in there, right? And it'll work just the same. Cool. Okay. So let's say he has a bunch of favorite numbers, right? And cool. Let's see, he has a bunch of favorite numbers. And he wants to print them out for the world to see. How would he do that? Anyone want to take a gander? Guess.
Maybe it's like print nums, right? Like,
Mm-hmm. But
like,
how?
Oh, it would be like print with like the thing equals nums, or no? Like I don't. Maybe I'm saying it wrong.
Like, how would I loop through the whole list and print out all its values? Like, give me the whole shickety-doo. I don't know what I just said.
I don't know. Is it like print dot nums, like print dot arrays of like nums or something like that? Or is there like a specific dictionary that you have to call in? Like an array.
I will give you a hint. That is what you have to put inside the loop. But how do I actually make the for loop?
Before.
Brian,
Oh, if.
Yeah.
Like if.
Sorry?
Like
I
the
heard-
if, like the if I thing. Like the function is what you're talking about, like that loop.
I think you're very, very close. It is a for loop, so I'll say that much. What do I have to do next if I want to iterate?
For num in nums, and then print.
Yeah.
Num.
Yeah, that's great. For num in nums, colon, and then indent. Always remember to indent. And then like the other person's, I'm sorry, I don't remember your names, but like the other person said, you would do print num, right? And you would print the whole thingity do. Oh, right. Let me just get rid of that. Yeah. And there we go. Okay.
Wait, I had a question. Why
Yeah.
did it go from num to nums? Like, why?
Sorry.
Why did it go from num to nums? Like, what's that for?
So let me make it more clear here. So the list, the name of the list here is a number. I changed it.
Mhm.
And basically num, what it does, num becomes each value in this list at each iteration. So let's just say at iteration 0, right? The first iteration, num is equal to the first value in the list, which is 1, right?
Oh, okay.
It prints num. You got it?
Okay, cool.
Yep. And it keeps on changing for each thing. So the next iteration will be 23, so on and so forth.
Oh, you don't have to define num, right? Because it's not a variable. You can just like.
Nope. You're technically defining it right here, but you don't have to do anything formal about it. You just say for num a number.
In other languages, you would have to, like in C or Java.
Oh, okay.
We don't talk about that.
The less
okay.
reference C, the better life is.
What can I say? Okay. And duly noted, Rojito. I've noted that in my mind, kept it a mental note. So here's a question. So I'm just gonna make a random problem at the top of my head. This is actually a pretty common problem now that I think about it. There's a bank and it wants to know if its customers. Actually, no. I think Rojito. Do you know what I'm thinking about right now? The
I
problem?
do, but I mean,
Do you want to explain it? I think you do a better job at that than I would.
okay. Right. Suppose you have a bunch of information about, your customers. You're a bank, and you have a bunch of information about your customers, legally collected. That's important. And you want to try to determine which of those customers is about to stop doing business with you in the near, like maybe the next 3 months or so. You can set that problem and define it, but there's a way to collect and store that information, and that's what Sammy's going to talk about.
Yeah, so each customer has these different attributes, right? They have age, gender, salary, number of credit cards they're already signed up at the bank. So the question is, we want to predict if a customer will leave the bank given all this information. But before we do any of that, we just have this huge, gigantic bunch of data. We need to process it. So what should we use to store this information? Anyone want to take a guess? Quick guess?
Like an array or dictionary?
Close. It doesn't have to be Python. It can be anything. I'll give you a hint. It has to do with Microsoft.
Oh, Azure?
Spreadsheet.
Yeah, spreadsheet. Someone said, I don't know who said it, but you get a brownie point. I promise I'll bake a bunch of brownies and bring it to campus.
I'll
one
ask
day.
you an INAG.
Okay, yeah, so a spreadsheet, you are correct. And basically, that's what a data frame is. A data frame is a fancy spreadsheet, and we use it all the time in this club. So very quickly, just like an Excel spreadsheet, we have rows, which represent each person in this case, and we have columns which represent the attributes of each person, right? And each one of these entries is called data, right? And this is from Geeks for Geeks, they're great, a website. So let's make some data frames. So the whole point of data frames really is just to analyze data. That's all it is. And data is really the best way to solve all of our problems. It's really, well, it is the way. So let's make some. So the way you make a data frame in Python is use this library called Pandas. If you don't know what a library is, don't sweat it. It's basically a bunch of code that someone else wrote that we get to use for free. Well, most of the time it's for free, but we just write import pandas because we want to import that code into our space. And we renamed the libraries PD just for short. It's like, my name is Samrat, but people usually just call me Sam, just as to make it easier. So the same way we're doing it here. So we do import pandas as PD. And then we convert the, well, usually we have data, it usually comes in CSV files, and CSV files are basically Excel files, right? So
Tiny
we use
note on
the,
that.
yeah.
Excel files are like, advanced CSV files. CSV means comma separated value. And it's just basically trying to store everything just as pure information in some sort of really simple array-like structure. And then you're reading it. Normally, Excel can open any CSV file. So that's, yeah.
Good enough. Yeah, I just like use them interchangeably now. But yeah, so in order to actually make our data frame, we're going to call our data frame df, as we often do, equals, and then we're going to use the read CSV function. But in order to use any function or anything from the library, we always have to reference it by the name of the library. And since we renamed the library to PD, we can just say PD dot read CSV, and that'll allow us to use a function. And that basically takes your CSV and like puts it in our program to use as a data frame. And then you have your data frame in this thing, this little guy. And a very, very common thing that you want to do is see the first 5 rows of your spreadsheet just to see how things are working. So in order to do that, you just do df.head, and that just returns the first 5 rows. This will become very clear when I actually do it for you guys in a Colab, which I'm going to do right now. All right, cool. Oh, that's the wrong Colab file. Here we go. Okay, so I have a data set already ready. It's called a Titanic training set. You can Google it if you want after the meeting. I'm not going to go into depth of it. It basically like predicts whether someone will like, survive or not. Pretty dark stuff, I know. But so basically how we actually get the CSV onto our little workstation here, Colab, is we use this bunch of code, just like, copy paste it. You don't actually have to know how it works. And when you run it, well, actually, let me reset the runtime. Can I? Okay, apparently I can't. And then you choose files, and then you get your file explorer, and then you just choose wherever you saved your Excel file, right? And then a lot of importing of libraries, just like copy paste, right? We're going to be using most of these libraries in our own project. They're not, you don't have to mug up the syntax or anything. But here is what I was saying earlier. We're using the read CSV function, and we're putting into this little guy, df. And what we're doing here is we're saying df.head. It's basically like, df, show me the first 5 things you've got. And it's like, okay, sir. And these are first 5 entries of the data frame that we have, right? So it's organized into columns, passenger ID, survived, P class, name, blah, blah, blah. And each of these things that are highlighted are rows. And oftentimes by default, the data frame will be serial. Let like each row will be given a serial number. So like it goes 0, 1, 2, 3, 4, stuff like that. Okay. You may be wondering about this. This is something with Google. It really, so me and Rohit and Chanel, we're trying to like work on a project for you guys, which we will reveal in time. And we needed to use a different encoding set. You don't need to know what this means at all. It's just like, again, just Google it. There's different character sets that make life complicated, and we have to deal with them. So yeah, don't worry about that. Any questions? I've been talking a lot so far ever since the last time I asked for questions. Any questions so far before we go deeper? No? Pretty sure some questions. I went through a lot of material. Yep, Rohit.
Can you
like
go
just like
over
sorry.
the difference
Yeah.
between read CSV and head, just to clarify?
Sure thing. So read CSV. All this is doing is taking your CSV file, the Excel file, right? I can like, oh wait, I'm only sharing my, let me not do that. So it's literally just taking your Excel file and like putting it into DF, like putting in our thing, right? So you have a reference to it, right? And df.head basically shows the first 5 entries of it, right? It's like, right, if you get a package in the mail, right? It's a pretty bad example, but if you get a package in the mail, you open a box and you just open it to, okay, fine, we'll make a Christmas example because we just had Christmas like a month ago. So if you have a Christmas gift, right, you really want to see inside, just a little peek. What you do is that first you have to get the package delivered to you, right? The gift. That's read to CSV. You get the thing from whoever's giving it to you, right? So you're in possession of it. That the gift is now DF. If you want to see, let's just a little peek inside of what it is. You just open slightly and open up a little bit just so you can see like the top bit of it. That's what df.head does. It shows a little bit of the spreadsheet, so you can see what's going on. Does
Wait,
that make
Sammy,
it clear?
maybe it'll help if you like load it and run each cell to kind of show in real time, if that's something.
So
Oh yeah.
Was the CSV file something that was already on your computer or something? Because
I did up here.
You said this was in like an editor, right?
Yeah, this is in Google Colab. So I actually got the CSV file by using this code, and it let me choose files, and then I just chose the actual CSV file, and then yeah, that's how the CSV got here in the first place.
Okay, so you just like uploaded it from your computer, and then like you made like a reference for it, and then you put it in that variable.
Exactly.
Okay, thank you.
Yeah, you were saying something, Rod. I'm sorry, I cut you off.
No problem. I was just saying, why don't you like just upload the file and then have it run cell by cell? Okay,
then I'll do a new screen share because I think I have to share your actual screen for them to see the file explorer.
All right.
Okay, so if I click on choose files, can you see my file explorer now? No?
Yeah, we can. Yeah.
Okay, cool. So I just opened File Explorer and I just happened to save my Titanic training dataset in downloads because like that's cool. And I select it and then I open it and waboom. The CSV is now in your, okay. Let me do that again. The CSV file is now in your environment and is now processing your CSV file.
Oh,
right?
Wait, I had a question.
Yes, sir. Go ahead.
So I saw that you said you can open CSV files in Microsoft Excel. Can you create those type of files and then like make it into a CSV file on Microsoft Excel?
You can even do it in Google Sheets.
Yeah.
Or Google Sheets. Oh, okay. So you like so you can create like the data sets and everything, like the data frame in Microsoft or Google Sheets, and then just use that code to upload it specifically here and then just read it.
Yes, sir.
Oh, okay, cool. Thank you.
No problem. In this case, I just downloaded it from the internet. So yeah. Okay, so we actually have our CSV file in our environment. Now we need the program to actually read it, like process it and put it into a data frame. And that's what we're doing here with the read a CSV function, right? And if you want to see, oh wait, sorry, let me just run that so you can see. Well, I have to import these first. Okay, now let me run this. Yep. So now your CSV is now in this little guy, DF. So you now have a reference to it. It is now a data frame. Congratulations.
Wait,
So
sorry, I didn't understand one thing.
yeah,
So
go
like, where
ahead.
did you get all this, like, all these imports? Did they like, are these auto-generated when you import the file?
These are just libraries.
Pre-written, like this was written manually beforehand.
Yeah,
Those
yeah, yeah.
imports
okay,
are
okay.
written in the Python script. Yeah.
Okay, I see. Thank you. And you need to import these in order to like read the CSV, right? Or like, what are these imports for?
I needed to import only this for the stuff that we've been doing so far.
Okay, and then
This
the rest of it is
pandas.
for like other stuff.
Yeah, it's for other stuff in the
Okay, cool.
beneath regions of our file.
Oh, and I had a question about encoding. What is encoding? What is UTF-8?
I think
Right.
Rapito had a great response in that chat.
All right. So information is expensive to store as the characters that we're familiar with, right? So there's some sort of conversion and abstraction going back and forth between the system and us. If we want to read something, it has to be in these letters, you know, UTF-8 or Latin letters. It has to be in some human understandable form. But if the machine wants to store them without the need for a human to read them, it encodes them and stores it in its own kind of weird little language. So when we specify while reading the CSV that we want to decode these in UTF-8, we tell it that these have been encoded in UTF-8. That's just one kind of encoding.
Oh, okay. Okay. And you just have to know UTF-8, or is there like
Yeah, you just sometimes you just need to try a couple different encodings to figure out which one it's been stored in. But the really common ones are UTF-8 and that ISO one in the comment next to it.
Oh, okay. So the stuff that we're going to be working with is usually going to be encoded in UTF-8 or
yeah.
Okay. Okay, cool. And you just have to let the computer know that it's in
that
UTF-8.
yeah, it's in UTF-8 converted to human readable, so it knows what to do.
Ah, okay, cool.
Good stuff.
Thank you.
So, is everyone clear up to this point? The read CSV?
Yeah.
Okay.
Sorry, I don't want to be like I don't want to be like rude or anything. But how much more time is this going to take?
We have 7 more minutes.
Oh, okay, so it ends at 6:30. Okay, cool. Thank you.
Yes. Cool. All right. So at this point, if we want to see the first 5 rows in our sheet, we just do df.head, like I said earlier. And in fact, to make it even clearer, since you can see my screen now, this is the this is the actual data set. This is the whole data set, which I am. Shut up, bro. I don't want to buy right now. This is the whole data set, right? And when I do df.head, it literally just shows me the first 5 entries, right? That's all it does. And if I run this, yep, shows me the first 5 entries. So what'll happen in a lot of cases is that data is never clean, right? I wish data was clean. We would have a much easier life, but in reality, data is never perfectly clean. Sometimes you need to rename stuff. Sometimes you need to change stuff, some values of data. So one of those instances of where we have to change the data set given to us is these column labels right here: name, sex, age, part, ticket, all that stuff. In this case, since we want the machine, since the problem here is we want to predict who will survive given the, stats, we want a binary response. Will they survive or will they not survive? So, because of that, we renamed it to label. And the reason for that will become a little bit clearer in next week's meeting. I think so. Is that right, Rapito?
Yeah, the next two meetings. Yeah.
Yeah. So just take it for granted right now that we want to rename the most important column to label, right? And how do you do that? You asked me? Well, you use what we learned earlier about dictionaries, right? And that is basically how you do it. So there's a function called rename, and basically rename literally does what you'd expect it to. It renames columns for you. So in this case, we take our reference to the data frame, which is df, our little cute df guy here, right? We do a dot, as we do with a lot of functions, dot rename, and we pass into the rename function the column that we want to replace the name of and what we want to change the name to. So in this case, we give it a dictionary. In this case, the key is our old name of the column, and the new name is the value. So the old name corresponds to the new name. I don't know why it's implemented like that, to be honest, but that's how it is, I guess. And yeah, so it'll do that. Cool. Yeah. And if we run this, well, first of all, so if we run this, okay, well, we don't know if anything actually happened. This is the reason why df.head is so important. We need to see what happens at each stage when we do something to our data frame, right? So now we know that survived has now been renamed to label very successfully. Cool. Any questions about that?
All right, the in place part. That just basically tells it to return a new data frame instead of the actual old one. It just replaces it with a copy with that modified column name.
Wait, I can't see it actually. There's something blocking it.
Sammy, you might want to move the chat window to the side.
Oh dear. Technology is great, isn't it?
Yeah.
So what does in place mean actually? I'm not sure what that means again.
Okay, so in this we just modified a column name, right? And we wanted to get a data frame which has the new column name as label instead of the one that said survived. And yeah, so in place will return a new data frame. If we didn't include that, then it would just modify the old data frame. It doesn't make a huge difference for this purpose. We just left it in there because it makes sense.
Oh, okay. Yeah. And we have to use that colon sign in order to rename a column, or is that just like a variable or something? Like column equals like that colon sign thing.
That colon, that represents the dictionary. That's a dictionary of a key on the left, which is survived, to a value on the right, which is labeled.
Oh, okay.
Right.
Cool. Thank you.
Yeah, stuff like this, like this dictionary right here, it's not stuff you really need to know the concept behind. It's just like you need to know the syntax behind it. Like you need to know like, oh, you would use these curly braces and then your old label will be here and your new label will be on.
Yeah, why do you use those curly braces instead of like a regular comma? What's the difference? Or like
well, these curly braces are really, it's just a dictionary. And the reason why we're using a dictionary, ask the person who made this rename function. That's just how it's implemented.
Oh, so you can like use different like curly braces, brackets, and like things to like better like identify it. Is that what you're saying?
It's more like that data structure is defined by those curly braces. If you're using a dictionary, you have to put the curly braces. If you're using a list, you put the square brackets. If you're using a tuple, you put the normal round brackets,
parentheses.
I guess. Yeah, those, yeah.
Oh, okay, cool.
It's specific to that data structure that you're using.
Okay, cool. And where can you find out what different data structures use?
You can Google the name of the method that you're trying to implement, in this case, df.rename, and it'll give you the documentation, and it lets you know what parameters go into that function to get your output that you want, like that.
Okay, that makes sense. That makes sense.
It's literally right here.
There we go. There we go, right there.
And this, remember guys, documentation is your friend. So if you ever have any doubt about it, just you'll go to documentation, it'll clear it up. Okay, I see now that we're at the 6:30 mark. We still have a little bit more to go, but I don't know, Rito, do you want to push it a little bit to next week, or because I don't want to like eat anyone's time or anything. What do you think?
I think we can this will probably take 5-10 minutes of the next meeting, and then we can pick up from where we left off today. So we can probably call it an evening.
Just a clarification for in place. So in place equal to true will not create a new object, and it will change in place. So for example, if you don't want to change your original data, and you want different, and don't touch it, so you can just do a different naming, and it will create a different object that would be exactly the same, but with the label thing.
My bad. I switched it around. So if in place is false, then the data frame is copied. If in place is true, then you're replacing the existing one with the modified value. I messed that up earlier, sorry.
Yeah, it's fine. It's fine. It happens, confusions.
So I want to take this time now to ask if any of you guys have any questions whatsoever. It can be about any part of this presentation. I'm available for about like a half an hour more. Any questions at all, I'm more than happy. But before that, we have resources. So basically, each of these links will help you in your Python journey. So this one is a great website. So if you ever have a doubt about any concept, let's say I want to learn about dictionaries, right? I can literally just click on dictionaries, and it has a whole tutorial about it, right? So this is like a great resource if you have like small doubts about stuff. And this one will give you like important concepts in Python specifically for data science. So that's another cool resource to look at too. Free Codecamp is an amazing resource. It's basically like, it's literally free. There's no strings attached to it. It'll give you like a module based class. I don't want to say class, but like course about Python. And that's a really good thing to look at as well. And last of all, well, not last of all, I have questions, but we have our meme of the semester. So look at it gloriously. Yeah. Anyways, I don't know why I did that. That's all, folks. Questions, please. Me and the leads and I are more than happy to take all of them.